We return to our IPython notebook to answer the question if we will have enough data for the chosen features. In this block of code, we draw some histograms. We have already seen what histograms represent. Let's first run the code, and then we will analyze the plots. Once it finishes running, you will see a histogram that looks like this. In this histogram, we're plotting the intersampling time in minutes in the x-axis. The y-axis shows the frequency for each of these intersampling times. The bins here are bins of 60 minutes. You see, the value between 0 and 60 has the maximum number of data points. If you scroll down, you will see the same histograms now drawn for each of the persons. In this case, this is the histogram for person A, and we see that most of person A's samples are also between 0 and 60 minutes. You can keep scrolling down and examine the histograms for each of these persons. In this case, this is person B, person C, person D, and so on. We ask the question if we have enough data for the intersampling time of 60 minutes. The answer in this case is yes. So we asked a question and then validated it by showing that there is adequate frequency of data. Then we come to the next question. Is there enough data to distinguish pattern? This is a very important question because we want features with the most discriminating power. What that means is that the features that we use should be able to separate each individual in the best way possible. We have already seen in lesson 2 how we can select features that give us the most discriminating power. Here, we are going to do a simple visual inspection of the data patterns and not dive into any of the methods previously used to decorrelate features. However, we must verify that the selected traces that we are using are distinct.